So this is our subject, what's in Java 9. I'm Tene, the CTO and co-founder of Azul Systems. And a brief introduction about me. I work at Azul Systems, and at Azul we make Java virtual machines. Java is basically the only thing we do. And given that we're building Java virtual machines, we run pretty much anything Java on servers and in embedded systems these days. From a technical point of view, one of the things I'm probably well known for is I've been working on garbage collection for a while now, and gotten to a point where we believe we've basically solved garbage collection in Azul Zing JVM. But here's some evidence of me working on the garbage collection problem very closely. This machine here is a trash compactor. It sits here in my kitchen, and a trash compactor's job is actually to perform minor garbage collections during the week, so that the big full garbage collection only needs to happen on the weekend, where I take the garbage back out to the outside garbage can. In this case, you can see that there was a problem with the compaction algorithm in the trash compactor. There were fragments coming out the back, and I had to actually fix it, and thought it would be funny to take a picture with the actual garbage collection book at the time. Probably the most important thing in this picture is it was taken in 2004. So I've been thinking this is funny for 12 years, and I really need a new picture, and we can move on from that. But I have a long history of building stuff, virtual machines, physical machines, operating systems and modules and drivers, all the way up to full-scale, nationwide telco management stuff with millions of subscribers and application servers and all the parts combined. So I've worked at many different parts of the stack. I've got 30+ years of experience in making lots of mistakes and learning from some of them. And one of my pet areas to talk about, which you might have seen online, is how people measure things like latency and response time and other behaviors of systems, and how they often do it badly and could do much better. My subject that's called How Not to Measure Latency is pretty popular for that. But that's just me. That's some background. The talk that we're going to talk about here started with what's in Java 9. And as I sat down to put together a talk about what's in Java 9, and after attending Java 1 for a full week, Java 1 is it's one of the most exhausting conferences I attend. It's a very hard-working conference. I thought to myself, people kind of know what's in Java 9, right? I mean, Java 9 has modules in it. That's what Java 9 is all about. Well, the reality is that Java 9 is not just about modules. It's also about some other stuff. And given that everybody else has been talking about modules and Jigsaw and those changes in Java 9 that are one of the main things of the platform, I thought that I would kind of focus on the other stuff, or at least some of the other stuff that is in Java 9, and parts and things to zoom into that might be small or of specific interest to me, and I would like to kind of go into those, and as we go through them, I'll pop back to overall questions and directions for the platform as a whole. Something I forgot to mention about my involvement is I'm one of the Java Community Process Executive Committee members. I represent Azul on the executive committee. We look at the overall roadmap, at the overall standardization of the platform, and things like IP flow and things like that. We also participate heavily in OpenJDK, both in maintaining and shipping OpenJDK free products, but also maintaining old versions and contributing towards new versions that will come in the future. So with that, you'll see that some of my interests are specific to things we've worked on. So let's look at what this other stuff is. Java 9 has a bunch of things in it, and one simple way to look at that is you could go to the OpenJDK page and look at all the things that are currently in plan included in Java 9. As you've probably heard, Java 9 was originally aimed to be shipped in March of this coming year. and has recently been shifted by about 4 months. So we'll see it in the summer of 2017. This is the current list of things that is intended to be included, and it's a pretty long list. Some of those things are platform visible things, things that change actual behavior, things that change the spec, the API, new features. Some of them are very much under the hood, semi-invisible things, or whether they're performance improvements or support for additional things in CPUs and new platforms. They're not actually changing the Java platform per se. And OpenJDK works on both things. The overall set here is very long. I will focus on 4 specific things, and I've highlighted them here. The JShell, var handles, unified JVM logging, and one of my favorites, SpinWeight hints. So let's look at those and kind of go into them one by one. The first one I have here is simple. It's JShell. With Java 9, Java finally has a REPL. A REPL stands for read, eval, print, and loop. And with a REPL, Java actually is moving into the era of modern runtimes, which is very simple. Virtually any modern environment that is used for development actually has REPLs, the interactive ability in a shell to evaluate things, to interrogate the runtime and the current state of stuff. And we can define modern as starting with Lisp, which is where the first REPLs appeared. So, when you look at this feature, it's a pretty exciting feature because it lets you do things you couldn't have done before, but it really also is one of these real features. Once you have it, you kind of wonder how you ever did without it. And I do think that it's very exciting that Java will finally have this capability, because if you look at how people actually develop and try things in a lot of more of the rapid development environments out there, the fact that there's a shell that lets you interact and probe like this is very useful. This will probably show up as an integrated feature in most IDEs very quickly. I think NetBeans already has it, but we'll certainly see it with other IDEs as Java 9 actually comes out and starts being directly adopted. I'm not going to get into what a REPL looks like or what JShell actually looks like. You can find plenty of material online on this. And it is just like what you would get in a linear environment, autocomplete and everything. It's a really cool feature, and I think it's one of the more exciting ones for me as a developer. When we look at additional ones that I highlighted here, var handles, which is actually a very cool but very technical feature. Here's a definition or the key goals of what var handles are meant to do. They're here to define standard ways of invoking things that are similar to Java util concurrent, atomic, or unsafe operations on regular objects and in arrays, but without going through the unsafe path, without having to break the rules of Java and the JVM and use something that may not be supported in the future. The idea is that there are certain operations that we can today only do on atomic variables that are defined under Java util concurrent atomic, and we actually want to perform them in pretty much any field of any data in Java. Regular fields on objects, elements of arrays. And those operations include things like volatile access, volatile reads and writes, maybe atomic access like atomic compare and set or swaps. Those are all operations we want and need often. And when we look at what people do to do those kind of things without actually using an atomic object to do them with, they go through certain hoops and loops that are either very unsafe or very crude. If any of you have already run into what an atomic field updater looks like, you've probably gone through the exercise of trying to make those kind of things fast. The other part that you often see is that ordering, the actual memory model itself for Java, only applies when operations that are volatile or atomic in nature, or synchronization is involved. And we often run into the need to perform memory model ordering operations on regular fields or on elements of arrays without involving some other volatile or some other atomic. And var handles are really going to help and change that. Now, I mentioned SunMISC Unsafe here, and that's a very important thing to understand and to keep in mind where var handles are concerned. SunMISC Unsafe is unsafe. It's unsafe by definition. It says so right in the class name. It's also not part of Java. It's not part of the Java spec. It is not a class that you can rely existing in the next version of Java ever. In fact, it's not a class you can rely on existing on every Java implementation that you might run your Java program on. But in practice, SunMISC Unsafe has been used so widely in the last several years that all JVMs de facto support it as an API. And while we all tend to be very unhappy with the fact that there's this very unsafe, unspec'd API out there, we pretty much have to support it because there's functionality in there that is not available in other ways, both for performance and for certain functionality on objects. var handles are intended to cover a large part of that functionality to make it virtually unnecessary to use unsafe for any objects on the heap, for any access to arrays or to object fields, to have a standard safe way to access those with high performance. Now, a common question people have had about Java 9 and Unsafe, and you guys have probably heard the rumors about this and the arguments going back and forth, is that Unsafe might be taken away, might literally be deprecated and taken away from us. And it's the interesting thing is to realize that there's nothing to deprecate because Unsafe doesn't actually exist as a Java SE spec. It's just a de facto unsafe, unstandard, unspec thing. And there is the long-term intention to slowly eradicate the use of unsafe in the Java world in order to remove it, because it creates big problems, both from a safety point of view, but also from a performance and stability point of view, and from the point of, it prevents certain optimizations and future developments that the JVM could have done if unsafe wasn't there in prevalent use. So what we'll see with Java 9 is an attempt to provide alternatives to unsafe that are valid, safe, and the right way to do things, and then to try and get the various users of unsafe to transition to use those new APIs. And in using those new APIs, remove the use of SunMISC Unsafe from existing code, existing libraries, so that at some point in the future it would be removed. But to be very clear, with Java 9, SunMISC Unsafe will still be there, will still be available. You would just need to use this flag when you run your Java applications that use that feature in order to expose it. Now, in addition to providing things like access, atomic access, and other access that is equivalent to unsafe to fields, ordering is one of the other things at school that has been added to var handles. Specifically, we can now use ordering fences that do not involve accessing a variable. So it's not that you have to read a volatile, or write a volatile, or lock something just in order to create ordering. There are explicit fences defined in APIs. One of the important fences, and sort of an interesting corner case, is the one I highlight here. There's a new reachability fence, whose meaning is basically that the variable that you pass into it remains reachable until that call. In this use case, the actual code that you see here is a common way to protect a method or to protect the content of a method from having a very surprising effect happen to the object that it's being run on. Unfortunately, in today's Java, there is a prevalent bug that has to do with the this pointer, the this object, actually becoming unreachable in the middle of a method that is run on that object. And that's a very surprising effect to a lot of Java programmers because you would intuitively think that this code right here represents how methods are currently run. Well, they're not. And under the current rules for Java and under the future rules for Java too, a method being called in an object does not mean that the object itself is alive for the duration of the method. The place where this actually comes into play is around things like cleaner handlers, phantom reference handling, and removal of resources like off-heap memory or file descriptors or whatever other resources you might have with finalizers. A finalizer or a cleaner could actually be executed in the middle of a method and an object in a surprising way unless a reachability fence like this is used. So this is a much needed corner feature that allows us to fix an entire set of bugs that is currently in the Java code, both in regular Java users, but also in the JAK itself. And I think it's an important feature. It's also an important feature for people to realize if they do perform any kind of finalization or resource cleanup on their code. I'd encourage you to go read up on this. Moving on to the next kind of area I wanted to zoom into, we have a new logging system in the JVM. And the unified JVM logging is there to really clean up the mess that has been built over the years in the various ways that we log things from the JVM. Now, to be very clear, this is not a logging system for Java. This is not a logging system for your applications. It's a logging system for the JVM itself to log information you might want from it. And all these flags that you see here are examples of things that people have asked JVMs to log and trace and put somewhere over the years. Probably the most common logging mechanism you're aware of is the GC log, but there's a lot more than garbage collection that needs to be logged. Compilers and de-optimization and various VM operations and freezes and save points that have nothing to do with garbage collection are all things that need to be logged somewhere at some point. And we have had sort of de facto various logs that would include that, the standard output, standard error, the GC log itself that has existed for a while is a specific log for garbage compiler information. System with Java 9, you have this new world order logging by the -xlog flag. And the -xlog flag takes parameters that would control what gets logged and how it gets logged. And I'm not going to get into the details of all those. There's actually a very good and very detailed talk that I referred to here about unified JVM logging in JDK 9. It was given at Java 1 just last week, and you can probably find both slides and references to it online. The important thing to understand is the places where log files will show up, the content of those log files, and to some degree the format of those log files is going to change with Java 9. It's going to change for the better in a way that would hopefully make parsing logs and managing them much more robust. But it also means that as you transition to Java 9, there may be compatibility issues with things that actually parse current logs. So this is something to be aware of. In a way, this is bringing the Java JVM logging system to be in line with other modern or more robust logging systems that let you set levels, set the different resources or facilities that are being logged and control them in various ways. So logging is going through a complete revamp, which is a great thing because having written things that scrape and parse the logs and having dealt with the fact that the logs are sometimes corrupted by multiple threads writing to them and the text from them being intermixed between them, I'm very much looking forward to a more sane logging system that we can reliably scrape that stuff from. Now, the last small feature I'm going to go into before kind of opening this up to some discussion and talk about Java 9 and beyond as a platform and direction is SpinWeight Hints. SpinWeight Hints is my favorite feature in Java 9 for the simple reason that I'm the one who created it and contributed it. So obviously it's my favorite. It's also probably the smallest feature in Java 9. When I say small, I mean this. SpinWeight Hint adds a single method to the JDK. That method is Java-lang thread on SpinWeight. And that method does absolutely nothing. That's a fine trick, right? But it does absolutely nothing really fast, or it makes doing nothing faster. The specific intent of onSpinWeight is to allow spinning loops to execute faster, or more importantly, to react faster to the thing that they're spinning and waiting for. The common use case for onSpinWeight will look like something like this, a spin loop of some sort that is actually testing to see whether or not it needs to be done spinning. And normally you would do this without this call in the loop, or that's what things would do today. You will find this in a lot of high performance code, messaging code. You might see this in implementation of the disruptor and other patterns on where a thread is busily waiting for an event that it wants to react to very quickly without having to go to sleep or wait or block. And in fact, this pattern is very common in the JDK itself in various implementations of Java util concurrent primitives. So things like the locks themselves in Java util concurrent will do a certain amount of spinning before backing off and blocking. The purpose of onSpinWeight is to hint and tell the JVM that we are in the middle of a spin loop, and that if there are things that can be done about this spin loop to make it behave better, to react faster, to do whatever it is that will improve performance of the spin loop, the JVM will now know to do them. Now, the hint is fine, but what the result would be is more important. And here's the actual example with measured data of the improvement in reaction time of a spin loop with and without this spin hint in a loop. The yellow line here reflects the time it takes to measure time. So basically nanotime latency itself. So that's a baseline. You can't be less than that because that's how long it takes us to actually measure the time it took to do something. The red line is the code I just showed you without the SpinWeight hint in it, and the amount of time it takes to perform a round trip back and forth from one thread to another where both of them are spinning like this. And the blue line is the same exact code and the reaction time for that code when the onSpinWeight feature is included, and it is included now in Java 9. So this is a measurement on a early access Java 9 JDK. You can see that there's a very visible difference, a difference across the board, across all percentiles, where the reaction time of the loop is faster, and faster by a significant amount, by somewhere between 1/3 to 1/5 of the time that it takes to react for a thread. And that comes into play quite a bit when you look at high performance code at the logging code. What I'm very happy to see is now that onSpinWeight itself is being used heavily within the JDK, and we're starting to see uses of it when Java 9 comes out in an early access stuff in libraries that do high performance spinning with Java. So, with that, I've covered the few features I would want to zoom into, which are not the common features that you would hear about in Java 9 talks. There are many, many Java 9 talks you can follow and listen to, and I encourage you to do those. In fact, there's a couple, I think, in this 24-hour virtual jug that we're talking about too. And the interesting kind of question to ask that I often ask is, which one of all these features will actually make people move to Java 9 or attract them to Java 9? And the real answer is we have no idea. This is where I'd actually like to hear from the audience, if you'd like to chime in, as to what things you might have found in Java 9 that would attract you to it and would make you decide to adopt it sooner rather than later when it comes out. So with this, I'd like to open it to Q&A and some open discussion.
All right. It's been a short session, but nonetheless a very interesting one. You went over a couple of features, and yeah, you are still screen sharing. I think if you just disable that.
There we go.
Then it will be perfect. So Roberto, you are joining us from sunny California, I guess. Do you have any questions about Java 9?
Well, not that many. It's not done. Well, actually, I have sun here, but I'm actually in Seattle.
Wow, sunny Seattle, that's a new thing.
Yeah, sunny Seattle, the new thing, yes. So trying to see if we have any questions here from our RC channel.
Yeah, the RC is not very active yet. I have a question though. So there are multiple features. You showed us like 3 screens of just the list, and you just went over some of your favorite ones. At the same time, we all know that, well, Java 9 has been late again, and the modularity is not a fully solved problem yet. Do you think it will stop or prevent the adoption? And do you think which set of features, because of the backwards compatibility issues, do you think it will be a non-issue for the majority of developers? Or if you think that would be an issue, which parts of the changes in JDK 9 will be this moving power, the incentive to actually overcome all the challenges with modularity and actually move forward with Java 9?
That's got a lot of aspects to it as a question. So let me break it down to this. To start with, yeah, Java 9 is going to be delivered late, but it's a very large project, and the modularity part of it is one of the largest. Cracking that has taken a long time. As you know, this has been worked on since before Java 7. It's been sort of a roadmap item for a long time, and it's finally going to see the light of day with actual modularity implemented in Java 9. Is that modularity the full set of features that everybody has wanted? No, it isn't. A few things in it have been reduced or cut, and will probably make it to a future version of Java after that. But I do think it's an important step in the right direction. In modularity itself has a lot of benefits, and you know, being able to move out of the class path hell and the jar contradictions and the versions and things like that. Unfortunately, I believe that while we will achieve modularity for the JDK itself, modularity for code that runs on the JDK, for the regular Java code that most people use, will be there to some degree, but a lot of the things people have been hoping to get from modularity are still not going to be there in this version. For example, the ability to deal with multiple conflicting versions of the same library used by multiple different libraries you might depend on is still not going to be there as part of modules in Java 9 as I understand it today. But it's certainly a feature people are looking to do to add in the future. So versioning has been sort of taken out of scope to a degree. Whether this will affect adoption, I don't know. I think that modularity as a driving feature is interesting for some set of people, for people who build libraries, who build large complex systems. And some people will start restructuring their code this way, but really from a friction point of view, you know, Java is doing pretty well today. And I expect that pretty much everybody who is running on Java 7 and Java 8 today, and will hopefully move to Java 9, will take their time before they actually restructure things so they will only work on Java 9. The actual natural evolution of libraries and modules takes a long time. I myself write some open source libraries that people use, and I've only recently started considering writing them to something later than Java 6. And the reason for that is if I write code that I want people to use, I need a common denominator level. I would love to use Java 8 features. I would like to love to use Java 7 language features. But I actually have been keeping my level of Java for the library low so that it'll be commonly usable across things. For example, I've added functional APIs to my Java 6 code, but I do not force people to use them. They can use the regular way. I think we will see a similar transition with modules because as people modularize their systems, they still have to deal with the fact that there's plenty of Java 8 and probably Java 7 and maybe a little Java 6 out there. So when you put out a module for the world to use, you're pretty much going to force people to use it on Java 9 and Java 9 only. I do think that this will happen over time. I think it needs to happen over time, but it's not going to happen when Java 9 comes out. It will probably happen, that transition where people will release code that doesn't work with older versions of Java will probably happen when Java 10 or Java 11 is out. Until then, we'll see sort of a mix. People will provide either the old way of doing things with just jars, which will absolutely work with Java 9, or they'll start providing both, but not let go of the old. And it will be at a point where people are fairly confident that there's new Java 8 left, that we'll see that. That point is probably 3 or 4 years from today, not today. So this is a step in a road in the right direction rather than a point where everything flips over. Now, the other part of your question was about adoption. Let's slow down adoption. The last question I had in my slides was, what features will actually attract people to Java 9? And I really don't have a strong answer to that. I think that there are certain features that are exciting to certain people, but there isn't a systemic language change. Probably the only true systemic change we can point to is the module system. All the rest of them could be seen as interesting evolutionary steps. So for example, if you really want to have fast spin weights, you would need the new API and move to Java 9. If you want certain new stream API calls, or you would like to remove some of the boilerplate from packing collections and other collections, there are nice features in Java 9 for all those that could attract you to do them. But it's hard to see any one of those being the reason to say, damn it, I want to do Java 9 now. There's this feature I really have to use, and I must move today. I think it'll be much more of an organic shift, sort of like the shift from Java 6 to Java 7, which was not a fundamental new language thing. There were just new capabilities that people wanted in libraries and slowly moved to them. Java 8, which is fairly recently behind us, was a big stepping stone in Java. We had new language features that developers wanted to use, and developers pushed for the new Java to be used, and we're seeing a very strong adoption of Java 8 as a result. I think that the last time that happened before Java 8 was Java 5, with the introduction of generics and Java util concurrent. But Java 6 and Java 7 were both similarly incremental versions of Java that added capabilities, expanded the platform, were very important, very capable, but didn't have a fundamental everybody must move or the new way you write code doesn't work anymore kind of behavior. And I think Java 9 is looking somewhat like that, a good, healthy, incremental release. So that was a very long-winded answer.
It was a long question as well. And I think I agree with you. And then Java 10 will come with value types, and that would be maybe a massive incentive to upgrade. However, we have another question, and actually a technical question from the RC. So mpast_even asks, say you have multiple threads that are spin weighting at the same time, and there are more threads spin weighting than their CPU threads. How does the JVM handle this case? And if there is an overhead, or if there is a loss of speed in the form of overhead?
Yeah. So this is a common question for spinning in general. It's not specific to the JVM. I would say that it's common to what I would call user mode spinning, meaning not a kernel spinning and not a tight loop on a CPU, but something that runs on an operating system as a thread and is spinning. This is generally considered a bad idea, or has been considered a bad idea, or something you should be very careful about doing, exactly for the reason the question was asked. If you end up with more spinning threads than there are cores or virtual cores to run them at the exact same time, usually you fall off a performance cliff. Usually things become really, really bad, really, really fast, because spinning code is usually there intending to act very quickly, sometimes even holding a resource while spinning. And it pretty much works on the assumption that it will not go away for 10 milliseconds and not run. And if it does, you start having situations where something is waiting for the spinning thread to react. That something itself might be spinning. And in spinning, it prevents the CPU from being free to actually handle the thing at once. And you fall off a cliff very fast. So historically, and even now, I would say this has been a either don't do this at home or do it very carefully kind of thing. The reason it's changed, and I think it's changed more and more in the last 3 or 4 years, is because we are all running on heavily multi-cored machines. Machines with more than 10 or 20 virtual cores are commonplace. My laptop that I'm talking on right now has 8 virtual cores. And on Amazon, you can rent a machine with 100 virtual cores, but it's commonplace to have, 16, 32, those kind of things. And when those are used responsibly in environments where you know what the system is being used for, the use of spinning could be extremely beneficial. So the common places we see spinning used is in a very careful case where you have a handful of threads, sometimes 1 or 2 or 4, that are specifically dedicated for a spinning function, and able to dramatically improve the performance, run at much higher throughput, react at much better latency, compared to anything that they would do with blocking code. So that's the general statement about spinning forever, I would say. And spinning forever is useful, but carefully. You have this other mode of spinning that's existed in user mode for a really long time, which is a spin with a back off to a block, or a spin with a back off to a yield. And those are still there and very useful. So for example, virtually all locking systems, including POSIX locks, including the JVM itself, when you go and grab a reentrant block or a synchronized block, if they can't actually grab it, they will do a certain amount of tight spinning before they give up and do the slower path. And the reason that's an important heuristic thing that is developed over time is because there's a very common pattern of ping-ponging things where one thing holding the lock is noting or notifying anything that needs the lock. If you just wait a few microseconds, you'll be able to grab the lock. But if you give up and block, you would spend tens of microseconds just getting it back. So these heuristics happen a lot at the lock library levels in the JDK itself. You can find the code for that in Java util concurrent if you want. And it's exactly these kind of spin loops that the SpinWeight on SpinWeight call that we had added it helps a lot in optimizing. It optimizes both the reaction time to the spin and tends to reduce the power consumed in the SpinWeight, which tends to let things run faster or better in general. But to bring it all back to the original question, yes, this is something to be very careful of. Spinning more threads than you have CPUs is always a bad thing.
Good. I think that that was a very sophisticated answer to that question. We don't have any more from the RSC, so I have one more question that I'm personally very interested in. And you mentioned REPL, right? And this is something that all the languages have. And do you see that would be actually useful in Java? And do you see that competing with other means of, like, how do you see REPL being used from a standpoint of a typical Java developer in the shop? So they have the IDE, they have the processes running, they have the debugger, and they can evaluate like short expressions anyway. And the REPL kind of comes sideways to this picture. So if you do have an idea how to use that proficiently.
So I look at it, and I've played with the JShell in the early access JDKs, but I can't say that I've gone through a full development cycle that used it as a tool. But I have used REPLs quite a bit in other environments, and I think that if you look at the cycle, the coding cycle people go through, when you're sitting down and thoughtfully structuring a class, a REPL is not going to make much of a difference. And IDEs, especially for Java, have become extremely powerful at pretty much answering anything you might need to know as you write code, with autocompletes, with inspections, with whatever things you use in an IDE. If you try and write Java without an IDE, so if you just open up Vim and wrote it in the nice colors that it has, but had to actually look up a Java doc for everything as you go, that would be much slower. I used to write Java like that before IDEs existed. And I could say that back then a REPL would have been a necessity just to be able to answer questions of, wait, what can I do here? What, these autocomplete interrogation sort of reflection-like things on code, just to know what the options are. But it is fair to say that IDEs are very good at doing that without needing a REPL per se. You mentioned debuggers, and obviously in a debugger you can evaluate things in a similar way. But there are so many cases where you have this very short cycle where you're trying to do something or answer a question or say, wait, how does this behave, or what does it exactly do? And firing up a program, entering a debugger just to ask the question, often writing the program just to be able to run the debugger on it, is a very cumbersome way of doing things. The thing I think to learn from is take a look at what people who write Python or JavaScript or Ruby or Groovy do when they code, and they usually will have some sort of a REPL window open that they can interact with. Simply because it's a way of answering questions quickly. It's a way of trying things out very quickly. Very quick experiments, not actual full-scale coding, but you then usually held it open right next to the thing you actually work on, and it saves you time and work. I expect that to show up in Java as well, and there are so many cases I can think of where I literally went to an IDE, fired up a program just to enter a debugger to be able to answer my questions, to the point where maybe most people have this. I have a dummy program just for that purpose. So you can use a debugger as a REPL. I don't know if you do, but I think a lot of others might have gone through the same thing.
Yeah, I do.
Yep. So the fact that you have it means you've kind of hacked your own REPL, and a REPL with more autocomplete capability would be even nicer to have.
No, yeah, and REPL has a really cool ability to list all the methods and imports that you previously entered. So it's a fairly sophisticated tool rather than just something where you put one-liners in.
Yeah, and JShell is pretty cool in that it has the simple autocompletes that you would expect, but you can import code and increase your scope, autocomplete within it, and even do things like autocomplete that'll show you the various overloaded options of a method. If you have the same method with 3 overloaded parameter types, you can autocomplete to see what they are and interrogate that. Again, this is something most IDEs will give you as you write the code, but the ability to do it as you type into the REPL is very nice.
True. Well, thank you for the insightful answers. We don't have many questions from the IRC, and I think I've reached to the bottom of my prepared questions. So thank you for the session. It's been really great. Once again, this was the keynote session for the Americas region of WIJAC 24, and you have wonderful Jill Tene from Azul. The session was sponsored by Couchbase. Once again, NoSQL database. Check them out. And another sponsor that sponsors all the sessions these days on the virtual JAG 24 is JetBrains, and they're giving out licenses for their tools. And the winner of the license for this session, session number 17, can you imagine we run 17 sessions already? So the winner is Gerrit Muhlmann. Will contact you, Gerrit, and congratulations. Thank you, again, and we'll be really soon back with the next session. And let me just figure out what that is. I know what that is actually, but I will need to put up the splash screen slide for here.
So, while you're doing that, let me ask you a question. This is a 24-hour JAG, right? So how are you guys running this? Are you taking turns and shifts? Because I hope you're not staying up for the whole 24 hours.
No, that's a great question. Since we have a couple of moments, I can maybe elaborate. We are not sitting here for full 24 hours. We have shifts. So the whole team behind the virtual JAG which is the virtual JUG itself. It's an online-only JUG, so we have some experience running online sessions. We have a full library of them, actually. And at some point of time, we had this idea that we would love to have this larger event that will unite Java developers all over the world and will heavily promote the local JUGs as well. So for the most of the sessions here, we found a local Java user group for which the time of the session would be appropriate. And they joined us here in the same Hangouts as we're running the session with you. And it was a great experience for them, and it was great for us. And it's really fascinating to see the community react to this. It's a little bit of silliness, actually, to run this for 24 hours. But the sheer challenge and epicness of the endeavor attracted a lot of well, publicity, and so more people learned about us and more people joined. So we are currently a fairly large Java user group. So virtual JUG is 10,000 members large, and that is an amazing feat, and we are extremely proud and happy that we achieved that milestone. And so for the VJUG 24, both Simon Maple, who is the founder, myself, Roberto Cordes, who you see now in the Hangouts from Tommy Tribe, and Ivan Ivanov. Roberto and Ivan are running the book club for the virtual JUG. So we all joined our efforts to make this possible. And without all these other guys, neither Simon nor I nor anyone else in the very small team would not be able to do this. So
cool. Well, it's a very cool idea. As I said, I think this is the first time anybody's done a 24-hour virtual event like this, I think. This is not you haven't done a 24-hour before, right?
We haven't. We just had individual sessions. So this is new for us as well. Hopefully we'll have everything running smoothly without any issues, and hopefully people will continue. So I have a new question from the IRC. IRC has unhibernated themselves. So do you know how is Azul doing with implementing Java 9? And if you can share any information on that.
Well, if I don't know, who would? But yeah, hopefully I would know. Yeah, we are absolutely implementing Java 9. You know, we currently ship Java 6, 7, and 8 in both our Zing and Zulu products. And Azul makes two JVMs. We have Zing, which is sort of a better JVM, has better metrics, you know, doesn't pause for garbage collection, scales better, faster, better response time, that kind of stuff. And we have Zulu, which is basically OpenJDK. Zulu is an OpenJDK binary distribution. It's well tested, supported. You can download it for free from the web and use it on a Mac, on Windows, on Linux. Both of those products are Java 6, 7, and 8 today. You can actually get an early access Java 9 Zulu right now. You can find it on our website. And with Zing, we will ship a Java 9 Zing once Java 9 is complete. You can look historically at our behavior with previous Java versions, and Azul has been shipping Java since Java 4, Java 1.4 is what it was called at the time. And you know, we regularly follow the release cycles, both major and minor. And I think that given the common adoption cycle for a Java release, it takes somewhere between 6 and 12 months for people to start putting it in production. Developers usually want to play with it earlier. We expect to see a Zing Java 9 within weeks or a couple months from the Java 9 GA release. We'll probably have early access before that, but we're not looking for, you know, GA production quality to hit the same date with Zing, simply because we don't see a strong reason there. With Zulu, you will see exactly the same as OpenJDK, and since Java 9 is being developed as in OpenJDK, we simply have matching releases. We don't expect there to be a lag between OpenJDK and Zing that's more than, you know, the test and ship kind of lag that is normal. We don't make any big modifications or anything. It's simply a build of OpenJDK on these platforms that is well tested and certified.
Good. So it's running well. Thanks again for all the time and the session and sharing the knowledge. We'll be back soon with the next session.